In part 1 we followed the journey of Irwin, in a story that served as a metaphor for the very real weirdness of quantum mechanics. Now, we must go over the experiment for which the metaphor served. This experiment laid the foundation of quantum mechanics and is our first step towards answers. We start today's journey with a simple question. Imagine you shine a flashlight on a piece of paper with two rectangles cut out. What design would you expect on the wall behind the paper? Two bands where the light is, with the rest of the wall being dark, of course. But what if I told you, the pattern changes if you close your eyes? And it changes not because of some trickery, but because the light knows when you're looking. This is not a made-up result. This was actually observed in real experiments and laid the foundation for the field of quantum mechanics. Here is the story of this experiment. Otto sat in a dimly lit room, going over his calculations. He was studying the properties of light and wanted to settle the debate whether light was a wave or a particle. He had worked through several pages of calculations and had reached a conclusion. He had set up an experiment with a lamp pointed at a board with two narrow slits in it. Behind the board was a screen. If light behaves like a particle, then turning on the lamp would cause two bands of light to appear on the screen. He had decided to call these particles photons, if this were the case. If light was a wave, and not a particle, an interference pattern would appear on the screen. It would be either one or the other, and Otto would finally be able to resolve the debate and establish himself as a legend in the physics community. The universe, however, pays no heed to how one wishes it would work. He eagerly walked over to his lamp, pointed it at the slits and turned it on. Immediately, an interference pattern emerged. Otto jumped with joy. He had finally done it. He rushedly went about gathering all the papers around the room, his mind full of thoughts of prestige and renown. In his hurry, however, he accidentally bumped into a table on which sat a special detector. Otto had acquired this detector, especially for this experiment. If it had turned out that light was made up of a beam of particles, he could have placed this detector in front of the slits and found out which slit each individual particle had gone through. A wave, on the other hand, goes through both slits at the same time, as if we were pouring water over the slits. The device would not register anything when encountering a wave. Bumping the table caused the detector to fall in between the light and the slits. As Otto went to pick it up, he looked up at his beloved interference pattern. In its place was now only two thin bands of light. Otto was shocked. Perhaps the detector had hit something else and ruined the experiment. Not quite. Otto had simply discovered how the universe works. If we were to recreate this experiment with modern technology, the results would be the same. As long as we don't know which slit the photons are passing through, we have an interference pattern. But as soon as we place a detector before the slits, which tells us which slit each individual photon goes through, we make a measurement. A measurement changes all. Somehow, the photons know we are looking and decide to behave like particles instead of a wave. Remove the detector and the interference comes back. Wondering how a particle can know if it's being watched and change its behavior accordingly? How could that even be possible? Well, it gets even weirder. What if we put the detector after the slits, in between the board and the screen? Now the photons have already gone through the slits, and have already decided if they are going to behave like particles or a wave. So putting the detector here will change nothing. We have outsmarted the universe. But the universe is always a step ahead. Even with this setup, the particles seem to know in advance, through some impossible clairvoyance, that they are going to be measured after they pass through the slits. They change how they behave accordingly, And again, behave like a wave when the detector is not there and like a particle when it is. This introduces a fundamental rule: somehow, a measurement changes all and the results of any event in the quantum world change, depending on if we are looking. Think this is weird? Perhaps impossible? Well, let me assure you, this is the truth. We are just starting our journey and things are going to get much weirder. Follow along for part 3, where we dive deeper into these questions and reveal even more secrets of the universe.